Okay, welcome everybody. Today is the 23rd of January. This is Dallas Personal Robotics Group, Builders Light Night Online. Tonight we have a busy meeting, and I'm going to show a few slides that we haven't shown for a while. Just as a reminder, this is kind of free to attend. Membership's not required, but annual fees do help with DPRG costs. But anyhow, it's not mandatory. Been around for quite a while, 501c3 from the U.S. tax code, Uncle Sam point of view. And I think everybody is online is pretty familiar with what we do. This is the slide I did want to get to. So please mark your calendar. We have on the 10th of February an annual meeting coming up. And I think there will be an election with, if it goes as I think it's going to go. Probably I'll give a little outgoing term discussion. Then it's somewhere, I don't know what order we'll do it in, but a robot show and tell. And then the incoming slate new president will give a host of planning, I guess. And then we already have made plans now for Roborama this year in spring. It'll be a quick trip, 4 square, 5 spots, 6 can, and I really think we need 7 something with that kind of a run. But we got those contests at the moment. Who wants to join? Let me.
This is a physical meeting?
Yeah, this will be virtual. The 10th of February will be in person, and of course we'll do. I mean, everything we do hybrid now too, so we'll do it virtual as well. Okay. But I have booked the makerspace rooms for these, or I've requested. Actually, it's booked for the 10th, and it's pending approval for the practice session on the 27th of April, and the competition on the 10th of May.
That should be 11th, because 10th is a Friday.
Thank you so much for, okay, 10, 11, all right. 4, 5, 6, 7, then we're missing 8, 9, 10. But okay, so anyhow, that's what I wanted to share from the normal startup. So I'll park this for now. Then so far for Q, we have Mike with a shorter thing, I guess, Jai with Iron Rain, or Jay with a longer thing from Iron Rain. Doug D has a quite literal smoke test. I have a shorter item, kind of an interesting note from Tesla World, and then I have like a 45 minutes, maybe an hour presentation on CES. So that's the queue that we have. And then if there's any time left, we have open mic. So I'll just post this into our little chat window and say, Mike, why don't you lead us off into this crazy evening tonight?
All right. Well, it sounds exciting. So I'll start sort of unexciting. And so I tried to dive into Ross's navigation stack and quickly found myself drowning. So I put it on the back burner. And so I said, okay, I'm going to use their Fusion stack just because I want to add an IMU to my unit. So I just tried to put my encoders into it and my wheel encoders and have the wheel encoder.
Uh-oh.
Oh, no.
There you go.
Huh?
We lost you.
You froze again.
I froze?
Yeah.
Cool. But let me change my internet interface.
Latent freeze from Dallas.
Well, I shoveled 4 inches of snow this morning, I'll have you know.
Oh, very nice.
Switching to freezing rain now as we speak.
Yeah.
Awesome.
I think San Diego had almost 4 inches of rain in some places.
I got a light dust of snow in north of Austin.
All right.
Just briefly, which sends all the people down here in a panic.
No doubt. Shuts the city down, doesn't it?
Yep.
We got 6 inches last week of snow, and within 10 days before that, we got 16 inches.
Very nice.
No.
Must be
Yeah, I don't know
white
if
out
anybody
there.
saw the flooding in San Diego, but it was like washing away cars and
Well, last week I was farther up north. I was 4 or 5 hours north of here, and they don't have enough snow. They only got about 6 inches underground, and they can't go to a snowmobile.
Yeah. Well, I was changing my internet connection and it didn't like it, so I came back in. So I tried to do the fusion thing and it seemed to work, but then when I tried to drive my robot, because it was supposed to just do a conversion and I didn't use the conversion, it was acting funny. Oh well, so I got a lot of debugging to do in that. I don't expect any help from anybody. I'm just letting you know. And one thing I did today is I pulled out my new OpenMV camera. It has a big number to it, so it's the newest one that they just released. And pulled out the IDE and put it on my Windows computer and on my Linux computer, and it seemed to work pretty good. You can run it in really high definition, like 2560 by, well, you can run it in HD and higher than HD. And when I did that, I could see an orange can across the room. So that was pretty cool. But it was only like running at 1 frame per second, so it's probably not practical. But that's about all I'm doing right now. One thing I was going to ask Ray, if he ever tried to write extra code inside of OpenMV's IDE to do stuff besides just camera stuff. Like in particular, hook up some sensors and then process them and send them out the serial port as an independent thing.
Yeah, there was a seed. I'm going to say it was a Seed Studio part. It's a small time of flight imaging sensor. It'll do like 100 by 100, and it had a serial port that would work up to like in the 900,000 baud range. And you can basically send it a serial stream of what that 100 by 100 time of flight imaging sensor saw and process it with I think it's an H7 processor, because that's what it's an OpenMV H7. So I've done that. I've used it for the challenge line following course. That was a thing. I thought.
So the processor on the OpenMV board, you can process other sensors and use that sensor data some other way. Because I saw some libraries or some examples in there that said it could sort of fuse a depth sensor with the camera sensor, and I didn't dig into it, but I was trying to figure out if I can send that data directly to my Raspberry Pi along with the information from the OpenMV camera stuff.
Yeah, I imagine you can. You can do, the H7 is a pretty fast processor, and it's that's what the whole part's kind of made for, is to do image processing. So, and he's, I think, optimized pretty much every routine that you can think of, and he's got, I don't know, literally hundreds of examples of stuff, whatever it is that, you can do with an image. He seems like he's got an example for it. The other thing that I was talking about, and I showed it, God, I don't know, a long time ago, 5 years ago. And I thought about it for the 6CAN and CAN contest. If you have a laser with a line lens and it draws, you set it so it's drawing a horizontal line with the laser. You can, if you have the laser like pointing out parallel to the ground and the camera pointing down towards the ground, you'll get a depth image from that laser line, because things that are further away will appear higher up in the image, and things that are closer will appear further down. And so you can get basically a one-line depth or field of view. Well, no, not field of view. A one-line
Depth
depth image of what you're seeing in with the camera. So, and it works great in low light conditions. I actually found a band pass filter that I could put on the back of one of the lenses, and that, basically just let the wavelengths of the laser through. It's an infrared laser, so you can't, it just looks like a faint pink glow. I can kind of see it with my eye. So I think it's near the, not too far away from the visible red spectrum. But with that band pass filter on it, basically it really sharpens up the image. You don't get any other light that could throw you off, or from heat sources. And it worked surprisingly well. It would go at least 15 feet. But I've never seen anybody incorporate it into ROS or anything, kind of like the LiDAR data. But you could do it, and it would be a lot faster. You could get at least 20 frames per second out of it, which is a lot faster than what LiDARs may whip around, maybe at least 5 times a second. Or I don't know if Chris's goes faster than that, maybe 10 times a second, 10 hertz. Yeah, will it go that fast? Yeah. Anyway, so yeah, used it quite a bit.
Okay. Well, I'm looking forward to doing it someday. I just wanted to break from my beating my head against Ross. So.
Oh yeah.
Yeah. All right. Well, that's my update.
Was that the RT1062? Is that the one you're using?
Yes. I received it a couple months ago and haven't unboxed it, and said, I'm going to do something fun. Okay.
Okay.
All right. Thank you, Mike. Very good. Jay, I think that leads to you then. So the floor is you. How is Iron Rain doing these days?
Hello, everyone. Can y'all hear me okay?
Oh, yeah.
Okay, so this last weekend was our last of our meets, where we do a couple of league meets, and then that determines our seed going into the tournament that's next Saturday. And so we got a couple of good games, and I'd like to show off our best game so far, if that's okay. And I'll kind of run through what the robot's trying to do, our future plans, and everything else. Sound like a plan?
Sounds great.
All right, I'm going to screen share real quick. Okay, can y'all see the YouTube video?
Yep.
So this is footage of our best match so far. I'll kind of let it play and talk over it. So this is kind of what the game field looks like this year, and that's our robot right there. So this first 30 seconds is entirely autonomous. It's detecting where that cone is, and it has to score the purple pixel right there on that tape corresponding to the cone. And then it drives out back and has to place that yellow pixel that you can't see very well right now onto the backdrop. You'll see how they stack up later in the game. And that's kind of an overview of what we do in our autonomous period. Now this spin is something I coded in too late with too little testing. And it's not supposed to happen that way. It's supposed to be a final heading correction to ensure that we drop the pixel on the backdrop, which is what this big black thing is, but didn't work out. And then we switch into driver controlled. So our driver now has control of the robot using kind of like an Xbox style gamepad. And what he does is he uses the big red belts to pick up these pixels, is what we call them, little hexagons. The red belt puts them in that white container, and then they get scored on the backdrop just like that. And so our goal this season is really getting this one cycle is picking up from here, going all the way back to the backdrop, and then scoring on the backdrop. And we're really just trying to optimize our cycle times and do cool stuff. And I'm the coder behind all this, or I'm one of the coders behind all this. So I'll kind of talk about future plans as far as like automation and stuff like that. And so you can see there's also a lot of like having to maneuver around other robots and kind of real-time decisions and competition pressure that our driver's under. So realistically, the more that we can automate, the better for them. So yeah, our robot comes out, score a couple more times, and then we go into endgame, which is really interesting. You'll see he doesn't quite pick up both pixels, but that's okay because we're going into the last 30 seconds of the game. And during that, we have to shoot off a paper airplane, which he'll do right about now. And that paper airplane has to land outside the field, which you can't quite see. And then the robot has to suspend itself on that red bar, which it'll do right now. And then it has to end the game in that hanging position. And scoring pixels on the backdrop, putting pixels on that tape right there, hanging, and shooting the plane off all score us points, and that's kind of what we're after. And so that's what our best game so far has looked like.
With
And
4 seconds to spare. Wow.
Yeah.
Gold star.
And so I think we scored 115, 118 that match, compared to last meet where we were in somewhere in the 40 to 60 range. And so we finally got some time to code, and that paid off. And so next steps really is making the robot more and more automated. So you can see a lot of this stuff the driver is doing is kind of going there, going back, going there, going back. And the plan is to have a ridiculous amount of sensors for this robot. So this is just our kind of first prototype for the robot. We have another one that's being entirely CAD'd by our design team. And here's what it looks like so far. It's carbon fiber, parts of it are aluminum. These are 3D printed parts, nylon. And it's just a more well-built, more cohesive version of our existing robot. And it's supposed to be really good in competition. And the idea is to make this robot as autonomous as possible. So the way I discussed this with Mr. V, our coach, right, is the way he explained it to me was the robot has to have a motivation, and that motivation has to align with our motivation. And so at any given point in the game, even when the driver has the controller, the robot is trying to do something. Ideally, that lines up with exactly what we're trying to do, which is just score as many points as possible. But we do have to break that down into a bunch of tiny steps for the robot. So the first step will probably be pathing around the field. And so the field looks something like this. Getting from here to here is kind of the biggest, most of our time is spent in transit, going from there to there. And so we have knowledge of this field as like a separate object, and this is kind of like an overhead that we use to diagram it. So the goal by pretty soon is to basically give the robot a target here and a target here.
It's not showing.
Oh, it's not showing. Let me entire screen. Sure.
There we go.
Can you see it?
Oh, yeah.
All right. So this is kind of what the field looks like top down. And the first step of aligning the robot's motivations with ours is to make the robot go from here to here and back and forth automatically. And the way we're doing that is it sits here, scores, and then it knows based on two sensors in that little white tray that I showed you. So they're somewhere within this tray right here in the new model. And they'll know when we have pixels within the robot. And when we have pixels, we should be looking to score over here. So the robot's target location will be right here when we have pixels. And when we don't, the goal is to pick up pixels. And right now we're working on kind of dynamically building these paths across the field and kind of getting the robot to run itself. And hopefully this is the really long-term goal, is that even during the driver control period, we can set the controller down and the robot will do everything itself. And there's a lot that goes into that. There's the sensors that'll tell you whether the pixels are in. There's the camera on the back that essentially scans these tags over here. They look like little QR codes. There's a decent frame. There's like QR codes back there. We call them April tags. They're simplified QR codes, but they also give you like how far is the camera from that April tag and all that data. And there's a camera on the back of the robot that reads those to help with A, relocalization, and B, kind of strategy in the way that we score, like stacking up pixels like this. And then another thing I actually forgot to mention during the game was that if you get the pixels in a pattern like this, where purple, yellow, and green are the three different colors of pixels, if they're all touching each other like this, then we get like triple the points or something, triple the points that just scoring them normally would. So we do want to know which of these parts of the backdrop that we're scoring on based on these. And so there's a camera on the back that handles that, as well as detecting this, we call it the team prop early game. So it detects that cone. So initially it's detecting this using a color blob pipeline, and then it moves back in and then detects for April tags. And there's a lot of optimization that goes into that, which is the real challenge there, because these robots are running on essentially Android phones from 5-6 years ago, and vision processing isn't their strong suit. So I think these are downscaled to like 240 by 480, the input that comes in, and we're polling at maybe 15 frames a second and running all the processing algorithms on that. And the plan is to do the same for these. And then we have distance sensors on the back of the robot. And so we have multiple sources of truth for our position, and maybe even some kind of obstacle avoidance with those distance sensors. And so, yeah, we're really looking at as much automation as possible. And ideally, we just don't have to drive the robot anymore, which is just something I've never seen before.
I was kind of curious about that. I do not think you need to, process like all your imagery in HD resolution. I mean, fewer pixels in a lot of cases is, otherwise it's like TMI, there's 1,000 pixels in your cone. And if you can find the center of it easily, then, I've even used like 160 by 80 images that, to get a frame rate up higher and stuff. So,
on the field, so looking at your, obstacle avoidance here, so you have a lot of static obstacles, like the middle of the field, the playing board. You also are going to have dynamic obstacles with the other robots. How are you going to deal with, the reflexive behavior of avoiding dynamic obstacles? You could do the static obstacles with some sort of planning, but you can't deal with the dynamic obstacles. How are you going to do that?
So the dynamic obstacles they're kind of going to be a guess and check. Our driver's obviously still going to be there for insurance purposes. And if the robot's going straight at another robot, our driver should be there to stop it. Dynamic obstacle avoidance is something we can kind of guesstimate because the robot should always be driving in the direction that the distance sensors are pointing. So essentially because the robot's, like the big red intake is usually pointing down towards the letters, and the robot's backside, or the way it scores pixels, the big flipper thing, is always pointing that way. And the plan is for the distance sensors to be on the back. And it tries to do as much of its pathing as possible, pointing backwards, sort of. So, obviously static obstacle avoidance is the way that we're dealing with it right now isn't too complex. Whenever it reaches one of these points, basically if it reaches past, say, 1.5 in this coordinate system right here, it'll snap onto a hard-coded line, because that's the safest way to get it through. It'll snap onto that hard-coded line, say 0 through 6, and then it'll try and find a straight line path or a spline out to the target.
Okay. And I assume if you're doing it that way, that your odometry, your dead reckoning is pretty good, pretty accurate.
As of now, we're using the onboard IMU because our biggest issue before was our odometry wheels. Basically, we have dead wheels on the bottom of the robot. This is what I demoed last time. We have these on the bottom of the robot, except I put these in by hand, and I'm not very good at building robots. I'm pretty okay at coding them, not very good at building them. So a little bit of misalignment, a little bit of imprecision in the way that these are placed down to the millimeter affects how skewed our heading is. That was a huge headache until Mr. V reminded me that we have an IMU within the robot. So we have an IMU in, wow, you can't see it in any of these photos. We have an IMU in that black box over there, and we're using I'm pulling from that every 2 seconds and storing that as our heading. And so we have technically 2 sources of truth for our heading. One of them isn't very good, but in the CADed model, there are machined places for the precision milled places for these pods. So ideally they should be pretty good as well.
Ooh.
And we trust these enough to not slip. And also we plan to actually relocalize whenever we get to different points in the field. When we get near the back here, if both distance sensors are firing, they can find the distance from the robot to this black thing. So essentially we get a distance in this axis. We get a really, really reliable location in this axis. That also happens with these QR code looking things, the April tags. They give you a live, where is your camera relative to the tag? And
So you can,
by the size of the tag, you mean?
yeah, by the size. So we hard code in the size of the tag and the angle it's facing at and all that.
so you can zero your recalibrate every time you go to the board.
Mm-hmm. Yeah. Probably relocalization right here. Around this part of the field is where we have the least sources of truth for our position. But the idea is that over the course of a match, we're going back and forth multiple times. So we should hopefully have a pretty reliable sense of position.
I noticed the thing has clear walls on it. Do time of flight sensors not work on clear plastic?
Sorry, time of flight.
Yeah, are those your distance sensors that you're using, or?
I'm not sure. I'm not too sure what time of flight sensors are, but we're using the optical laser-based ones.
Oh, okay.
Yeah.
Yeah.
Yeah, we're using time of flight sensors.
So they only work on the black? Say it again.
Sometimes they don't see it.
Hey, you're breaking up, Kareem.
Sometimes the distance sensors see right through the plastic.
You do? Okay, yeah. That's what I was wondering.
That's an interesting problem.
Yeah.
But where that black backdrop is, that has a good solid activity, and so they got two distance sensors there so that they can also get their angle, so they can also correct the heading if they get two readings.
So I assume that since you're using odometry there, that the manual driver doesn't affect your overall localization. So normally when it's just dead reckoning and autonomous, the robot's keeping track of all that. And if you throw in manual operation, it has a tendency to screw up that dead reckoning. How are you dealing with that?
So essentially, the way our motors are driven, like by the robot, and the way that our position is deduced are two completely pretty different things. The way our position is deduced leads to the way our motors are driven, and not the other way around, because of these dead wheels. They allow us to essentially, they're not driven at all. So they just roll on the ground, and they tell us where we are based on how many times it's rolled on the ground. And whether it's the driver doing that or whether it's us kicking that, it has a really, really good sense of where it is.
So it's not affected by the wheels flipping.
Yeah.
Are you planning to do autonomous for the dynamic obstacle avoidance?
I mean, we're as of now, obviously very little of this is implemented. But the plan is that we have the robot pick the most optimal scoring, and then the driver deviates away from the most optimal pathing if there is a dynamic obstacle on the way. Eventually, if we can get those distance sensors or the camera or some other kind of sensor on board that can do some kind of dynamic path that can gain some kind of knowledge of where the dynamic obstacles on the field are, maybe we could have a fully autonomous robot.
Cool.
So, Jay, you got two questions here. Mickey's asked about the human driver and whether that throws off odometry, and Jim has asked whether you're using magnetic compass or what kind.
Mr. V responded with, we do have a magnetometer in the IMU, we just don't use it. And then driver control doesn't throw off odometry more. Really, nothing tends to throw off odometry other than like imprecision in the way it's implemented. Basically, these I essentially eyeball the alignments of these, so they're not down to the millimeter precise, and that's what's throwing off our heading and our position and all that. But whether the driver is driving it or the robot is moving autonomously or I kick the robot, it doesn't really matter because these wheels are driving either way.
Can you talk about how you mix the driver's command with the driver's motivation with the robot's motivation? How do you mix those?
So the plan is to have the robot kind of by default. The robot will do what it wants to do by default, which is it'll select the most optimal path from where it is based on whether or not it has pixels to where it needs to be, right? And if if the driver kicks in, say the driver gives it any input whatsoever, robot will freeze up and give back manual control.
A hard cut over then.
Hard cut. Yeah.
Okay.
The robot won't be like trying to compensate for the driver. Or either the robot is driving or the driver is driving, and there are obviously some like optimizations that like the robot is still correcting itself and ensuring that it's driving the way that the driver wants. But if we hand over the decision making to the driver, the robot is out of it. The robot isn't making any decisions for itself.
So driver input subsumes the Auton path that's active.
Bringing out the big words. Okay. I think, to my understanding, actually, for whatever it's worth on Tesla, I don't believe that the driver input fully subsumes the robot on Tesla. So I was just curious.
Hey, Kareem, I had a question about the mechano wheels. I guess you can't use odometry when you have mechano wheels because they slip?
You can. It's going to be pretty crappy when you're doing strafing in particular.
Yeah.
Like all odometry slips, right? It's guaranteed, especially if you're applying torque at the wheels. It's going to slip if you got enough acceleration. And with mechanisms, it's guaranteed to slip more, almost always. And and especially in straight. But you can do it. You know, it's just going to go out of, it's going to lose its truth pretty rapidly.
Okay. And
so it's pretty common for the all of the robotics teams who are operating on these off mats. Maybe 90% of them are using mechanisms these days, and most of those that have good odometry are these they like to call them dead wheels, but they're non-driven, coasting wheels. And
odometry pods.
Act like a mouse, right? And if you have, so you can have either two dead wheels and an IMU, or you can have three dead wheels, and the two parallel ones on the sides give you your rate of turn as well. And
rotation,
so what they're doing, what Jay's doing is a hybrid, where they're on the shortest durations, like every cycle, they're calculating their rate of turn from the difference between those parallel dead wheels, but then they're periodically updating it like every second or so from the IMU. So the IMU surface correction, and the main reason they're doing that is the IMU on this particular system, it takes 7 milliseconds to read any I2C sensor. And so that's considered a significant delay in the system. Whereas the encoders are all basically one bulk read per loop. And so they're tied together more efficiently. So we're just doing a periodic update of the heading. And then
do you need 3 of the odometry pods to do the angle? You can't get it from 2?
You can't get. You could get it from 2, but we've got strafing as well because we're mechanical.
Okay. All right. Yeah. Okay. Cool.
So we want to detect sideways shift as well.
So once those are bolted on, they don't rotate freely. They're basically giving you one axis direction. Is that true?
Yeah.
Okay. Yeah, I think Mickey had a question about how drivers or how a manual drive could throw off odometry. One way. So what he just mentioned with the slipping. So you can speed slew those motors. If you're not using that kind of pod, then your speed slewing motors, that basically controls the slippage, so your dead reckoning could be better. If you throw a manual driver in there, you tend not to have that speed slew.
Yeah.
So your slipping is going to be way worse, and your dead reckoning is going to be way off way quicker.
So yeah, that's kind of where we're at as a team, as far as at least the code side of things. The design side of things is moving rapidly towards this new robot and kind of machining all these parts and designing the interactions between all these parts. And we're looking to do pretty well this season, I hope. So we'll see.
So were you doing the carbon fiber to lighten it up, or? Wait.
Yeah, it's much lighter. It's much stronger. Having this big shield around everything made out of carbon fiber is also kind of style points, which does pretty well with judges. And it also serves to help us help protect the robot. So one big issue was that sometimes during the games, the pixels that you see over there would get stuck under the robot, and they just kind of stay there. And one of our matches, we just couldn't drive because of those. And then the worst thing is when they get stuck under one of these, and now our heading is all out of whack. And the thing about our driving is that it's field oriented based on the position. So forward for the driver, no matter which way the robot's pointing, is forward. And when we don't have a good sense of heading, that gets thrown way, way, way out of whack. And so these big shields should help. There's a lot more, lighter, stronger carbon fiber.
Rigidity should help with the accuracy as well.
Very cool.
So style points, it sounds like Ricardo Montalban. Is it better to look good or to feel good? I don't know.
And then what's the timing then for the rest of your season, Jay?
We have our tournament this next Saturday, and then a week from then. So basically, from the tournament, we advance to either semi-regionals or straight to regionals. The idea and the plan is that we try to advance straight to regionals because that gives us more time to work on our robot with less competitions. And then we move into regionals and then state and then hopefully worlds. We'll see. We went to worlds last year. We'd like to make it again. But short term we have next Saturday, and then a couple of weeks after that is regionals. Worlds is usually late April. So I think it's April 20th. April 20th-ish. Because for me, it's the way I think about it is it's right before AP exams, and AP exams are May 3rd-ish.
Perfect timing. Yeah, perfect, isn't it?
Yeah. No, we were studying for AP exams last year at Worlds.
Oh, yes. They pile it on.
Yeah.
That brings up. Sorry, that brings up a quick request for y'all to consider judging at the tournaments that are coming up. We've got one on February 3rd. We'll make it to the one on February 10th, which is our semi-regional, because we've got y'all have the yearly meeting on the 10th, right? And then 2 weeks after that is the regional championship. So anyhow, we need judges for any and all of those events, and if you need help thinking that through or how to sign up, just let me know, and I'll be happy to put you in the right path.
It's very cool stuff. You also judge. You get to see kids like me rant about the robot that they've spent hours and hours and hours building, and they're usually pretty excited about it, and you get to see what we're up to. Just more than just Iron Ring.
I've definitely enjoyed judging in time I've done it. Kareem, can you put in the chat here the dates, just so we have more clear record of that,
Sure.
concrete record. And then remind us again next Tuesday too. Yep. Cool. Well, Iron Rain's looking great as always. Yeah. Good.
Thank you.
Good luck from the club here. So cool.
Thank you.
Next we have Doug D. Then I have a shorter item and a longer item, and then open mic. So Doug D, are you ready to on camera live do your literal smoke test?
Yes, if you pin me, let me see if I can do this. This is the robot. Notice the mess of wires and such. No
Are you
big,
gonna wear safety glasses?
but
Fire extinguisher.
get a grip on
Yeah, you got a fire extinguisher.
It's the switch. I've wired in all of the encoders, and I'm going to see if it lights up or not.
Well, not literally like lights up, but you know.
There's lights in there that have come on, and nothing is smoking, so that it passes the test. Thank you very much for watching.
That seems
Actually, a very scary moment for me. And later on, I might be testing to see if I get any data from the encoders, but that's the full presentation.
Well, that's cool. But we need a star for that. That's
It didn't
good.
blow the motor controller, so that's a plus.
of course what he's not telling us is that he forgot to put the fuse in, so it didn't really get power. But
That's okay.
But there's a fuse on the power battery,
okay,
and the motor controllers actually suggest you put a fuse there, but I haven't. They wanted to protect the motor controller by putting a fuse right in front of the controller. I just didn't feel like it.
Yeah.
okay.
Next.
All right, next that would be me with the shorter one, and I got a short update and a long update. So the first one, I'll just put it into Slack here, and this is a Tesla full self-driving beta V12 alert. So basically, as I put in the chat there, hey, it didn't even cut it off. It would appear that this latest update from V11 to V12 has Tesla replacing something like 300,000 lines of C++ with neural nets. Neural nets. So think about that. And yeah, Mickey says what? And that's wow. So
It'll make it smarter.
all kinds of neural nets in there. Well, I just, I wanted to share my thoughts on this because the first is that I think about how difficult it is to write high coverage test queues. It's for anybody who's ever done it, it's really hard to do that and have actually proof of correctness for software. And then I think about how these neural nets, they're trained on zillions of human labeled test outcomes and also reinforcement learning labeled test outcomes. So it seems like as difficult as it is to write high coverage test queues, I don't know how hard it is to make sure that you have sufficient training data, labeled training data that's labeled correctly.
Yeah, they've invested a lot in auto labeling, though. So a lot of that data now is auto generated.
Yeah, but then comes the part though that think about the hallucination that we see for ChatGPT, right? Where you take the GPTs and you feed the GPT machine-generated output as training input, and suddenly the GPT gets stupider and stupider because it gets further and further away from the source of data. So,
Yeah.
Recursive.
yeah. I think others have raised that on this call. So I think, where are we going with this?
Recursive degeneration.
Yeah.
Yeah.
And then I think Okay, so my wife will tell you I'm being too negative about this, but I got to tell you, every time I drive our Tesla Y, it really annoys me because it gripes at me for for things I consider perfectly acceptable. And at the same time, it's griping at me for doing things that I think are I haven't had an accident like ever, and it's griping at me. And then it makes stupid choices, like it overrides my request to turn the turn signal on and off, right? It's a really basic command. Let's turn the turn signal. Key to safe driving. You get that too?
Yeah, all the time. That's my least favorite part of it.
I mean, even when we're in full driving mode, right? We're in manual driving mode. So like Jay had this where on Iron Rain, the operator will fully subsume robot brain. But for the Tesla, I have to fight over it as to whether I want the turn signal on and off. And I'm thinking, okay, how many decades have we had turn signals, right? It's a switch. It's on or it's off, right? On or off. And it communicates intent to other drivers, so it's safety. You flunk state inspections if the turn signal doesn't work. And here we have a case where the AI in the car, it can't correctly infer your desire to turn a switch on or off, even though you've already told it to turn the damn thing on or off. I mean, come on.
But I thought up there in Dallas, like especially on 635, the turn signal is the cut me off indicator.
Well, maybe that's where it's getting trained on garbage data somewhere. So it's making really bad decisions. But I mean, when I have issues like this, something as fundamentally basic as a turn signal where it's a switch, and I've told it what I want to do, and I can't trust it to do that. So I ask myself, why in any coherent universe should I trust it to make smart choices in more complex situations?
I think it's a cultural thing, though. People in Texas don't like to use turn signals, so maybe it knows you're in Texas and it's just trying to make you fit in.
In Germany, they're more reliable than your traffic light.
The car is owned by me, not Texas, and yeah, maybe it is more reliable than I don't know. So, on the other hand, this led me to another line of thought. So not to be too pessimistic, but I thought let's recheck the question. So maybe I should be asking I should not be asking whether the automation is good enough. Maybe the real question is whether I'd rather trust humans coding and training neural networks behind the steering wheel versus humans who are behind the steering wheel. So that's
a valid question.
That's the way I've tried to open my mind and stop being so pessimistic. So anyhow. And then here's another take. This is a guy who does YouTube videos on Tesla for years now. So they like his reviews enough. They give him early access, apparently. So anyhow, another perspective.
There was I think a company from Israel. They basically got tons of human input from. It was like a device you set on your OBD connector. And it would, use recordings of whatever video it had, and the operator's interaction with, brakes and steering and all that. So I think if they're using that kind of data, that should be, you know what to do and what not to do as far as training goes. So I'm assuming Tesla did some of that. So,
it's ongoing, right? They're all connected. Yeah. So as a part of as a part of your purchase and terms of use of the car, your data is being fed. It's anonymized and is being used as the training sets for these people that somewhere are labeling whether that's good driving or bad driving.
Yeah. Yeah.
I think you can deactivate that if you want.
Could be, yeah. Yeah, I keep forgetting Jack's another very familiar user with these little toys.
Yeah, I don't know. It seemed like all that driver training data should be better than, a human coder, trying to anticipate everyone's move and decision and with lines of code. So I don't know. I think I would trust it better than C++ lines of code. So
No matter how it gets there, when you put your tens of thousands of dollars vehicle, you put your butt in this tens of thousands of dollar seat, and it's barreling down the road at 50 miles an hour, and it stops because of a shadow,
oh, well,
or it veers into a curb, and you have to like, oh god, okay. So I don't want to be pessimistic, but that was anyhow. Okay, so we got. Are we ready for next in queue? We had my longer CES update report, and then open mic. So, any last thing before I start? Probably 45 minutes or so. Okay, hearing none. Brace yourselves because it is time for a visit to Planet Vegas. Oh my goodness! All right. So I went from Saturday through, I got home Friday, and I have a mix of a couple upfront slides and then a whole bunch of random photos. The first thing is Cirque du Soleil, and this time I saw Ka, and I just have to, it is a fantastic show, sight, sound, and story. I really encourage, I really support this one fully. And the other thing is that the venue is just remarkable. It is. I found myself not paying attention to story because I was trying to figure out how they got all the venue things to work as well as they did. It was just so cool. I mean, for the longest time, I kept turning around in my seat because I thought someone was singing right behind me. So I think the poor people behind me got disturbed, but it was the speakers in the seat. They were surround sound in your seat, and it was just phenomenal. And then they had a couple of these giant stages, and each of them had like 2 or 3 degrees of freedom. And they moved with performers on the stage, like 10, 20 performers on stage. These things would flip around. And one of them was like 25 feet by 50 feet. And it would go from fully flat to like diagonal angles to full up and down, different angles. And it also had like a projection touch screen. So when it turned from like a flat surface into a climbing wall, at some point these spikes popped out. While people were on the surface, these spikes kept popping out all over the place. And then they were strong enough spikes that when it was fully vertical, the performers could hang down on them like one of those things where the coin drops down in the thing. Except it was humans, and they were grabbing on these spikes that moments ago weren't there. And then as they moved down, the image projected on that stage or that screen would change based on their position. So I want to go back again, but it was just phenomenal. And okay, that was that one. And we're getting to CES, but this was the time I figured if I'm going to go to Vegas, might as well see whatever craziness I can see. So the Sphere, went to the Sphere, and it's kind of cool, I have to say. And you'll notice that they've got different things rendered on it at times. But this doesn't look very round at all, right? Or neither does this. Well, I can show a video of this a little bit later, but you know how Escher would take orthogonal spaces and map them onto like door handles and round objects. Well, they've done the inverse of that on this. So they've taken this round projection surface and they've convolved the image so that it looks like a flat screen. It is the craziest thing. It's the craziest thing. I'll show a movie of that in a little bit. But anyhow, so it's got so many LEDs and speakers. Okay, now I'm going to show a couple of things here. So audio beam forming demo. So before you, this is what you see on the outside, right? And this was, I recorded this afterwards, walking home in the dark. Let me find the video. Okay. So inside, if you get the tickets for the Sphere Experience, they have these robots. And they have this one is unique, and then they have 5 or 6 like it that do the same thing at other places. But this one is pretty cool because these are, I don't know, a couple hundred different speakers, audio speakers, all right? And just a quick show of hands, how many people have heard of beamforming? Okay. All right, so for those that aren't familiar with beamforming, what you do is through a whole bunch of complex math, you take and you feed independent audio drive to each of these speakers. That's been, I don't know, some kind of Fourier transform magic and whatnot. But it's done in a way that then it projects, like what they did is, you'll see it here when I run the video in a minute, but they had 4 or 5 different areas. So they have these rectangles on the ground that they lit up with lights from above. And within each of those rectangles, they would project a different audio sound from this big giant planar array. So what I'll do here is run this, and it's about 2 minutes.
Then you will hear a different instrument featured in each spotlight. In Spotlight 1, saxophone. In Spotlight 2,
Can y'all hear this?
guitar. Spotlight 3, piano.
Yes.
Good.
Spotlight 4, electric keyboard. As the track plays, walk or dance from one spotlight to another. Please visit all 4 spotlights and listen for all 4 instruments for the complete experience. Now initializing the blues.
So I started off on this side. And then hostess girl encouraged everybody to move. Sax, guitar, honky-tonk piano. Electric piano. So the thing is that I think it's hard to kind of tell just what kind of a guard band there was, a physical guard band between these, because the music, blends well together. But the quality of the sound, wherever I walked in that space, was just amazing. It was really amazing. And they gave a description that this inside the sphere, not only are there a zillion LEDs, but they have a zillion speakers as well, and they use this to ensure really good sound in every seat. And it did sound really good in every seat, although I didn't hear anything like spatial as I did in the Kaw Theater. But there was some kind of hokiness to this, I think, in a way, because here they had these banners by these robots, and this one said innovation, and under here it starts rambling on about quantum computing, and I couldn't understand why they were saying quantum computing has anything to do with beamforming. So I don't know, maybe I missed the point or didn't read long enough, but it was still really cool. And the other cool thing was that on the other copies of this robot, they had these little pavilion pods, like I say, 6 or 7 of them scattered around. And you can see how many people are milling around. And what they would do is at the other stations, this crowd would be around, and sometimes it took a little help from the facilitator person, but with only words and maybe sometimes gestures, the directional audio pickup on this, coupled with the vision, it let the robot pick out individuals in the crowd talk about, make reference to the kind of attire they're wearing. Oh, that's a bright outfit. Oh, that's a nice plaid. And then it would ask them, the robot would ask them, it would ask an individual question, and then it would pick out that individual's voice and interact with it ChatGPT style. So it really was a pretty cool demo. It was just hard to get much into it in that space. It was so crowded. So if you do this, I recommend go all the way to the back because there's less people there. All right, so yeah, and then that's so if you mix, that's what I was saying. If you mix computer vision, ChatGPT, and directional audio, C3PO, and they had a baby, that's what I think they did there. And then the movie that they play, I watched the movie called Postcard from Planet Earth. It's phenomenal. But let's talk offline about the plot and the message because that's an offline discussion. But the video and the imagery were really phenomenal. And then one of the drivers we had was talking about the costs of this thing. So apparently, what he said was the early reports were that it's bringing in something like $400,000 a month for advertising on the outside of the sphere.
So what does it cost to go to the sphere?
Well, they have tickets at $69. I think I paid $105 for a little better seat, times 2 because my wife couldn't make it, so I had expensive legroom. After all, and if you do it, okay, I thought this was one of the quirks that for a high-tech place, they need to figure this out. They only take mobile tickets, even though I couldn't find a way to print out tickets, so they only take mobile. But the thing is a giant Faraday cage, so my cell phone didn't work. So I had trouble downloading the tickets by the time I got to the place where they want to see your tickets. It's crazy. And then I'll put this in. I'll put this in the chat too. But there's some really interesting details on how many zillion LEDs. And then how they captured the imagery for it as well. So let me show you another few interesting things here. So I stood outside. There was one place where I could get really close. So you see the size of my hand there, right? I mean, that's what each one of these has about 48 LEDs. Neopixels, right? Like 48 neopixels.
Yeah, I kind of heard that those individuals ones right there, those round, were like a square foot of worth of space there.
Well, you can see, right? That's where I got my hand because that was within touching distance.
Okay.
So maybe that is about I didn't try and measure between them.
Yeah.
But damn, that's a lot of LEDs. And they talk about how many in that article.
So we can see that each one of those is. So, how much current do you need to supply to that many LEDs of that number of things?
I mean, think about it, right?
Because I know I've got one of these 8x32 NeoPixel things. I've got several of them. I use them on a few things. And if I turn all of those on bright and fire them all up and do the math, it's like 15 amps.
Oh yeah,
Hoover Dam level.
I mean, this is Las Vegas, built near Hoover Dam for a reason. But
That's
yeah,
right.
I mean, there's kiloamps going into that thing. I
look at that. I mean,
yeah. I was in Vegas back in October, and they had that stuff. I looked out once, and it had a big smiley face, like the eye of Sauron, looking at everybody, but it was a smiley face with a smiley face eyes on that. It was creepy as all get out.
it really is. So I have a few exterior things. This one I think shows it looks like a flat screen, It's just a big round flat screen.
So it's not a solid surface, right? I mean, air can pass through it, and rain and weather and everything else, or no?
It's definitely dry and air conditioned inside. So
Oh,
that
it
I
is.
think,
Okay, so
I
it
think
is
the
a
lights
solid
have a
surface.
shell.
Huh.
But how they get through and maintain the surface, I mean, I don't. But look, I mean, it just looks so flat the way they did that mapping of so that it views on it as a flat surface, because that's totally round sphere, right? But it doesn't look round at all there, does it?
Okay, so is the image projected on the inside and the outside?
No, that's the talk. Let's talk about how good this is for the environment, right? There's a layer of LEDs on the outside and a different layer of LEDs on the inside. So when you're inside the theater, it's showing a movie. On the outside, it's showing these ads.
Okay. Yeah.
So,
wow.
Yeah, I thought I saw at one point. I saw the Earth map to it, and it was rotating around. And one of them, I saw the moon. You know, at night, I was looking out my hotel room, and there's the moon sitting on the ground. And I'm like,
it's a freaky thing. Is that the right one?
Hey, Carl, if they are projecting that to look flat, do you have to be at the right position to see it? Or
well, you know, I couldn't move around that quickly.
Okay.
But from what I could tell, no matter what angle you were at, any angle where you could see it, decent. I think if you could see the edge of the sphere, it would look flat. From
interesting.
As far as I could tell. I mean, well, you could tell from that one that I mean,
yeah, that looked flat.
Yeah. I mean, it's
it just looks like a round, flat circle.
Yeah, a round, flat screen. So I think what they've done is they've made some assumptions about how far away you'll be, or actually the problem would be how close do they want it to look good. And
right.
Because the further back you are, the easier it is to do. Mm-hmm. If you think about the angles. But even there, I mean, the building was in the way, but it's still pretty flat even towards the top.
You know what else I'm pretty certain of, Carl?
What's that?
The people that built that thing and shot some stuff and did some things going, what do I need all this algebra and trig for?
No doubt. No doubt.
That is what you need it for.
And this is from the monorail. So there's anyhow, okay, that's not very exciting. What else am I missing? Okay, so I think that's it. Any questions for the sphere? All right, next slide, please. Next slide. Where is the next slide? Yeah, so I think it was worth it, but yeah, basically the message had to do with let's be green to the environment, and they were showing the message in the least green venue I could ever imagine. So, okay, next part of Planet Vegas, you know, the Luxor, this giant pyramid. Oh, what's that going on up there? Oh, so that's how they put the decal on a surface that size. It's a guy in a rope. Oh my goodness.
Shoes.
Oh my goodness. Okay. Oh, and then another Vegasism. So 130,000 visitors, right? And you need to go over the streets by these escalators or stairs, but half of them were broken. And it's been going on for years. Years. I don't know how many times I saw that. Pretty much every time I wanted to go down or go up, basically. That's what I saw.
When you're done later on.
Okay, and then let's talk about the Vegas Loop. All right.
Later on.
Tesla's, right? The boring machine. Look at this highfalutin thing. It connects 3 locations pretty much. And then there's an option if you want. You can take it out of the closed tunnel system into the open roads to some other destination. But okay, so before the next slide, if you know the answer to the question on this next slide, don't blurt it out. But we're all big on full self-driving, right? And here we have what? We have this nice tunnel environment. How hard could it be? How hard could it be? So is it autonomous? Well, let's take a look. Actually, I'll just jump straight ahead. I'll give the answer. It's people. People are driving these cars. There's no autonomous anywhere in sight. It's people. It's dystopian future right here. Okay, so let's go back. Where'd the video go? Yeah, so this is as you go down into the station. The cool part was that it would have been a 30-minute walk, I'm told, but I walked down. I never had to wait more than a minute or two. Hopped in a car, 2 minutes. I'm across to the other venue. So yeah. So, but that's all it was. Fancy light system. Look at that. Pattern on the walls. So where's the next one?
I was expecting it to be all automated.
Yeah.
You have to do it by hand, huh?
That's right.
Yeah. So these drivers, on a day like this at CES, they said they might make this ride 40 or 60 times. Just back and forth.
Oh, you're not driving it yourself?
No.
Okay.
Thankfully, it was free, but yeah, so I don't know.
I don't think that's so easy to drive in that tunnel. I think you're going to get tunnel vision. I mean,
Oh, yeah. Ooh.
Yeah, it's yep. So there you go. Okay, so now this is on. That was wow, 20 minutes of silliness. Now let's get more serious. All right. So the first serious thing I did was I went to the Intel keynote. CEO has been with the company for 40 years, and I'm just going to pull some items off from my notes. He spoke for 45 minutes or so. First thing he said was kind of cool was that he said, technology moves faster than products. Products move faster than business. Business moves faster than regulation, and regulation struggles to keep up. So that's how he set the stage for the whole rest of his talk, which was all about AI. And he said, let me see. Okay, I didn't hear it or see it in a show, but apparently there's a lot of talk about the AI PC or the AI server. And what he said is that once the PCs and servers to achieve a certain level of performance for an AI application, at one level you'll need a level of performance to create the models. At a lesser level, you'll need to just run existing models. But somehow you need neural network processing capability for all workloads. And he said once that gets more and more embedded, it's going to enable new user interfaces. Talking to the PC, new forms of UI. And he went on to say later on he described I'm mixing up sequence here, but a Cambrian moment for Darwinian, so that everyone's thought that the PCs have been dead up until now, right? It's a dying market. And what he thinks is that as the PCs start to incorporate these neural net chips that Intel is building, it's gonna be an explosion, like the Cambrian era in evolution. And he talked about cloud versus local, and basically he said, these days you have models where you need to build a model that has 1 trillion parameters, like ChatGPT, trillion parameters. That kind of work will be done in the cloud. But then for reasons of privacy and control and that not letting your data out.
Talk about how we actually make this thing
Smaller models, like with billions of parameters, maybe that you'll do on the local servers. But his basic theme was that there's no limit in sight. He said that from what he can tell, the cloud scale will just continue to grow and grow and grow. There's no limit in sight. He said at times he feels, because he's lived through like the PC days and the internet days. He said it feels like the early days of the PC, the early days of Moore's Law, the early days of the internet. Actually, he claimed to be he views it like the first few years of Wi-Fi. For if those of you were around for that, where there was nothing, and then for the first few years the chips were out there and there really wasn't much of anything. But then he described Centrino, where some standards body that he actually contributed to as a young jerk engineer, and once they drove that standard into existence, then came the explosion. Yeah, so Pat, 640K still be enough. Yeah, when will a trillion parameters just be? My watch does that, right?
The video link I just put in the chat, since it's a little relevant to you, Carl, is how to build your own sphere.
Cool.
This is like a 2 foot across thing he builds and puts together and things.
That's fun.
It just hit my feed the last couple of days.
That's awesome.
Oh, you probably don't want to.
Oh, I do.
At VGA resolution or what?
So
Carl, is he saying like currently in AI we're in mainframe mode where you have a green screen, and if you're lucky you don't have to have punch cards, but pretty soon you're going to have your own machine like a PC?
Yeah. So like he said, like OpenAI on ChatGPT, what they're doing, he said, is they're basically ingesting the internet, all the data on the internet, and they're turning it into a model, and they're doing inferences, like predictive AI inferences against that model. And he said, and this is where the regulation part he kind of kept in, I think, because he said he views it as a similar problem that the internet had at first, right, where people would have pointers to information instead of copying the information, but still, even when Google would regurgitate search results, there was all kinds of copyright issues at first. So basically, he thinks that technology will keep racing ahead. The courts will eventually come up to speed in the U.S. and Europe. As an optimist, he thinks the market will figure it out. He said it's not just about profit. He said that this is actually creating stunning and new economic value, new use cases. So in a way, he said the world is motivated to figure it out. And he said he thinks it's easily a 10-year era for different industries to really embrace it and make good use of it, because it just feels like the early days to him, a really exciting time. And then he also mentioned, I didn't put them in the slide here, but 3 laws of edge computing. And this is relevant because it's got economics. You've got local issues of physics, the time it takes to make the round trip between local and remote. And then there's the laws of the land, where you want to keep my data local versus let it out. And he thinks that those 3 laws of edge computing will generally tend to push more and more of these smarts from the cloud back into the edge, back into the devices like our robots. So all in all, but at the same time, I mean, they're building chipsets and scale for just crazy large, like ingest the internet and model it kind of scale things. So Intel keynote was pretty cool. And then, right after that, I got wind of this. I never did see it on the show floor, but here's a device that's very much in spirit of what he's talking about, AI PC. So here's a handheld device with a SIM card, I guess, but its primary interface is meant to be voice. and it's got a camera. And for $200, it's got a display. It's powered by a voice GPT style interaction. So you have conversational discussions. As a result of that, it brings things up and puts it on the display. So there's a whole bunch of articles. This is just one where they ask if this means the end of the smartphone era. I'll argue that I'd be shocked if Apple and Google let that happen, or the Android makers. But anyhow, yeah. So that ends the kind of slide part of this.
I got a friend that ordered one of those, and and it's a Kickstarter thing. And when I first saw it, they said, yeah, they sold out of the first 2 batches of 10,000. And my friend that he ordered, he goes like, no. I think I got one out of the 40,000 that they've sold for that on that thing.
Oh yeah, no, they were hoping to sell. They were hoping to get like 500 or 1,000 sold on the show floor, and they did that within a matter of hours. So they might have the Pebble Watch problem where they can't keep up with demand.
Yeah.
Okay, so for the next phase, I thought I'd just show some pictures and movies from around the show floor. So there was lots and lots of e-bikes. Let me make sure my notes are on the side here. Just a second. Get to my notes.
It's supposed to be how we're all going to get around soon on e-bikes.
Yeah. Just a second.
Yeah, if they don't catch on fire.
Yeah, or crash.
Yeah. Okay. I just didn't.
Catching on fire comes handy up north.
Well, there's an answer for you, Pat. Just wait a slide or two. Okay, so there was. Whoa! What happened here?
You're click happy.
I tested this earlier to get it working, and it just jumped it. Okay, lots and lots of robot mowers. Actually, lots and lots of robot pool cleaners, battery-powered pool cleaners, and I'm thinking, oh, who wants? Okay, as a pool owner, I have enough trouble with the hose-powered one. It's really jumpy on the mouse now. Sorry. This was kind of cool. I saw this in a few places. Haven't figured out quite how it works or dug into it, but here there's a real human against a backdrop. There's a guy on a computer, and then they've got this little hologram box off to the side, full size. And what it does is it kind of captures this guy's imagery and projects it in a way like it looks like he's standing there. So, and it was, I don't have any photos from being over nearby that, but it was really quite lifelike and real time. But they are somehow suggesting that you have these little like Barbie style gift boxes in different locations, and you want to go interact with somebody. So you'll go and stand in front of the screen, and then you're there with them, just like in the movies, right? Except for the box around it. So that was interesting. Lots of AI-powered wildlife cams. They were kind of cute. And this product, it won some award for a product award, but does anybody know what it is? No. Okay, we'll come back to this later, but I have to say that for winning a product award, they have the absolute worst display ever, because I still never saw it explaining what it is. There was tons of LEDs all over the place, all kinds of architectural and stylistic lighting things.
And this is an assault on the senses. Check it out.
Somehow I went there for a week and it looks like I didn't get a flu or COVID, but
It's just packed like.
it's just crazy.
Now this is a scanner. Or a contraption.
How's that for a nice scanner? I mean, this is a super high def camera.
How about that?
So Alexa will take over your lives if you let it. It appears that you can, if not now already soon, you can purchase these brand name frames and from an Echo frame, and then you can go have your prescription lenses put into it, and now you've got Echo on your head with the talking interface. And there was a bunch like that of that same kind of concept. I'll talk more about one of those later.
So just listening to your voice, not projecting anything on the lenses or anything?
I don't think it projected anything on the lens.
Okay. Yeah.
But I kind of missed it. There was, instead of a booth, Amazon paid for a whole like room, and you'd walk around, and they had a concept where the Echo is on your. The main thing was that it's on your eyeballs on the glasses, but it's in your car. It's watering the plant with an Amazon plant vase. I mean, it's just everywhere. In the kids' toys, in the smart displays, in the video screen. It was just, so they went through the life of a person living the Amazon dream. And that was just one piece of it with the glasses. And yeah, it was pretty much just voice. And it was not quite ChatGPT level smartness, but yeah, this is back on the crowds. I mean, this first stage just totally took it out of me because it was like that everywhere you went. It lightened up a little bit after that. Tons and tons of electric cars and electric vehicles. This is a brand new sporty little car with the retro styling. Some company out of New York. Pre-order them now. There was an entire hall dedicated to like automotive and vehicle things. It didn't contain everything, but it had stuff like this where a lot of the infrastructure subsystem vendors were showing off their bits and pieces that you could build into your vehicle. So there was tons and tons of stuff like that. And of course, you can't have CES without a flying car or a modular flying car. So they had videos of this one. And then there's another one, but basically this rover would unload the flying bit and then you could use that to fly around. And of course it's a 6x6. So all kinds of concept vehicle things. Here's one of the, there was lots and lots of radars and sensors for different ones. If you look closely at this, you'll see bounding boxes projected on the surface underneath of the object detected, even as far out as that truck, right? So they were selling, I guess, perceptive radar. And there was some demos I watched that were pretty cool in terms of the image recognition and that kind of thing. Of course, there's boats because consumer electronics, I guess, got to have a boat. Somebody had my display there. That was good. I appreciated that.
Nice showing there. Nice showing.
Got my own booth. Pat, this is for you, buddy. You still here?
Yeah, that's pretty cool.
It's ready for you. It's electric, Pat. It's electric.
Oh, so it'll get about 3 miles at minus 40.
It might even go in 6 inches of snow. It could work for you.
Yeah, you can be shredding up on that rail, man. I'm just saying.
There you go, Pat. All right. Something for
The
everybody.
hospital isn't that far away.
Yeah, until you caught a curb with that thing and it, flings you off into the snowbank.
Hey, you're landing in snow. It can't be all that bad.
Yep.
The curbs are already buried in the snowbanks.
Yeah, it's a curb rider.
Yeah.
And of course, this was a company. This thing hauls, is it 4 people or 6? But it's a VTOL, so all 8, I guess, swing up to do vertical takeoff, and then they swing down to fly horizontally. And they're setting up, or they're advertising that they're going to set up service between hubs like in California. You can imagine the cities. But this place, you know, I know what Nokia spent for a small booth that could house 10 or 15 demonstrators back in the day and a bunch of phones. I mean, that was $1 or $2 million for a show like this. This place, they've got this giant building. I just can't imagine what some of these vendors spent for what they did. Okay, this is the part where I have something I'll post into the chat window. This is so BMW. On the way out, I stopped by there. I didn't get early enough to get a demo of this in person, but the BMW has a concept where they've teamed up with these are X-Real glasses. And these glasses pair with your phone somehow, and then through the phone they pair to the car. But these glasses have a display on them. And through one of the links I put in there, the MSN review, they'll show you. But the idea is I took it, instead of a heads-up display where they project the image on the display, the idea here is that it projects the image on your lens, and it knows where your head is looking. So as you look around, it's able to superimpose the object in the scene over the point in space where you're looking.
Okay, is it using the BNO 085 or an 055 or what?
You know, let's read the specs. Yeah, so that's the X-Real glasses, and then until I got the name straight, it turns out there's an ongoing Kickstarter with something similar that you can do. So I figured, Ray, you've got your chick magnet you wear on the wrist. I think it's only a matter of time before one of us in the club gets some dude shades for robot telemetry, right? Some dude shades. So that was pretty cool. And I do have to say, I did a test drive of like a 2024 Mercedes EQG or something, and it had a nice heads-up display, and that was a really nice thing as well, just on the dashboard. Okay, then there's this. Good times, huh? Good times. Look, no hands.
Yeah, both hands on the wheel, man.
Not all the time. All right, so what's that nonsense? Okay, if you look closely, they had a camera on a robot dolly. So as it's going through that whole exercise, it just went through that pre-programmed thing, and I got to make my own little excitement video there. So that was the Nikon booth showing off their Z9 camera. And then, of course, it's a flying car, because what could go wrong with spinning blades around neck height? What could possibly go wrong?
That's why the car's so fast. So if you cut off somebody's head, you can get out of leave the scene.
I mean, it looks super cool. I believe that these blades and wings would flip back into the top part, but thankfully they didn't have these spin any faster than that, and I didn't see anybody try and get close. But Of course, flying cars.
Hey, man, they were promised in 1990. They're a little late.
Oh, and there's the concept for the other one with the rover. Just like Ingenuity. All right.
Yeah.
And of course, it's Consumer Electronics Show, so yeah. How's that for tractor? I have to say, it was fun to get up and climb in it and look out the front and just imagine. My wife's father-in-law has not quite this big, but it's just as fancy, I bet. And he's often sending photos of working hard from his office, which is basically he's peering over the sports page as his tractor drives around the field. And you can see the field in the background.
You know, that is kind of funny. Everybody's taught these, autonomous this, autonomous that, and driving this, and driving that. Farmers had this stuff for 20 years.
Yeah.
Yeah. Farmers like, it's an old hat.
It's an old hat.
But grow some more beets or something. I don't know.
But this is not quite the same as, pedestrians and
no. You want to run over stuff.
Opposing traffic, yeah. So okay, then there's this guy. So apparently they had a smaller model of this in past years, but this is now a fully robotic excavator from Hyundai.
So didn't we see this in the iRobot movie with Will Smith go nuts? I mean, we're just planning our own demise.
Yeah.
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 Did they get the idea from Kareem?
It might have been. But of course they had to have these flashy moving displays and
Now this concept is so much more polished. Tesla.
and this is I believe they call these concept pods, and this is where they don't worry at all about the exterior, but they try and plan what would the interior of a car look like. And this was at the Mercedes booth, and I just like the way that unlike the Tesla, where you have literally a 11 by 17, looks like somebody duct tape a display in there. These are just nicely part of the environment. And I actually saw one of these when I test drove. It had a display like that, and it still had way too many menus and things to try and find it while you're driving, but it is a much nicer concept in a way. Okay, now this is back to the worst display ever. Award-winning product, worst display. Can you look at this and tell what on earth it is? Any guesses?
Are they window cleaners?
It's a hoverboard.
Very close. So I believe I could not. I looked. I didn't bother to ask anybody, but I looked around. I could not for the life of me tell anywhere from the display what it was. But I'm pretty sure that these are robots that will pick up a car and maneuver it around and park it for you.
Wow.
I'm pretty sure that's what they are. They just roll on underneath, they lift it up, and they drive it where it needs to go. But good luck figuring that out from the...
Hopefully they don't turn evil and start stealing everyone's cars.
Yeah. I mean, and then let's think about lift point, right? Because it's not every car that can be lifted from an arbitrary flat surface like that, right?
Yeah.
Maybe it's an instant battery replacement.
I'm pretty sure.
I think Mike might be onto something there. I did see something where people were replacing batteries in an automated fashion because the idea is, it takes 45 minutes to charge your car or whatever it is. I don't know what it is, but it takes a while. But I thought I saw a service being kicked up where if you own a certain type of car, you can plug in here in 5 minutes. We give you a fresh battery. And it's like, I don't know what the service costs, but
Okay, let's just do a search. This is like a smoke test. Hi Mando, because that's what they have on their booth. HL Mando. HL Mando. The blue is lost in the black. Okay, so let's look for HL Mando. And their search stuff says realizing advanced human rights on a global scale. What is it?
Well, I don't think. I think you got the wrong. You got to be careful here because you may end up going to some place you don't want to go.
Oh, look! It matches, right? That's the same font. It's the same.
Yeah.
Mm-hmm.
Okay, so they've got four-wheel. Okay, well, what are they doing? Okay. Yeah. So it's apparently where endless possibilities open the way to freedom, and it's globally responsible. But it's an award-winning product, and if you can figure out what it is, I'm going with it's a lift to park cars, but I don't know. CES, and then Honda. This one I couldn't get a very good video of, unfortunately. It was all light show. I don't know what it was like to drive, or another concept car. Oh, there's the light. Yeah. Lights on every panel, basically. Lights everywhere. Lights inside, lights on every surface.
Yeah, because LEDs make it go faster and better knowledge.
Yep. And you go from that to this, another electric vehicle, some Bollinger, something like that. Just electric things everywhere. Okay, then of course the displays. So this was the LG always goes way over the top for their displays, their display of displays. And the big thing this year, I guess, was transparent displays. LG has a funny twist where they make it opaque or transparent. And it was hard to visualize what was going on because the displays kept moving around and the images moved around on the display. So I found another part where it showed it better. So my takeaway on these, and make no mistake, these displays looked really good. They looked really crisp, bright, good definition. But why would anybody want a transparent display aside from the cool factor? And I think there's two purposes. One is kind of like in commercial storefronts and the like. And then the other maybe is for architectural. So in this next movie, imagine where you have this big display separating two spaces in your home. And in one mode, you have the kind of black a backdrop up, and then you've got a nice display in one room, and then pull it down, and now you can have the fireplace or the fish tank that's visible from both rooms, because you can see the display from both sides. So, kind of interesting. And there's a bunch of vendors doing that now. They were. Last few years, they've been not only exorbitantly expensive, but unobtainable. Now I think we're going to start to see them be a little less exorbitantly expensive, but now obtainable, more obtainable. But you can see these, the way they did it, these giant black things have the roll-up for the backdrop.
This has to be the strangest booth I've ever seen at CES.
Now, how's this for a booth? This is another company that must have spent millions on their booth. But you just got to know what they do because it's not evident. I think they're a contract manufacturer, basically. So they had this little train you could ride around through the light tunnel. They had this AR ride where you could fly through space, and it's just,
Hey, Carl, did you get to see the drone soccer?
no, well, I kind of flew past that.
Okay.
There's in a couple places, but yeah, there was actually some places where you could try and fly the drone through one of the hoops courses, but
That's cool.
there's only so much time.
Yeah.
And, I was already walking 7.5 to 11.5 miles each day I was there.
Well, that's just normal Vegas walking.
Yeah.
CES walking. Yeah.
Yeah. So here's another one of these where they showed this is the same technology that they shot Mandalorian in, right, on that one, the volume out in Hollywood somewhere, just a giant LED screen behind the actors. So I had a really nice car, and you can see the produced video up in the top left. But unlike Nikon, which used the autonomous robot dolly, look at how it takes 3 people to operate this dolly, and then notice how they make the car shake appear. I get a big kick out of that. They just get the gal to bounce up and down on the dolly, and that makes it look like it's a bouncy ride. So the line for that one was too long. I didn't do it, but it was a much bigger display and pretty cool. And I guess they must have shown a display to the person so you know how you look. that they didn't do that in the Nikon one. Okay, this is cool, and I think we're getting towards the end. This was a Samsung. They call it Bali, and if you can imagine, basically a wheeled Amazon with a projector and ChatGPT. That's how I would summarize Bali. So it's a personal assistant that can roam around the house and do things. So this is a little demo. You get the idea. So you can be in your office and you can have it watch the pet or feed the pet. Or it can project a butterfly for the pet on the ground. It can wake you up. It can turn on the lights for you. Take the dog for a walk. Follow me to the study. I have to make a video call, right? So there's the video call projecting on the wall. Conveniently set up. Let's work out. So here's your workout on the screen. How's the biometrics doing? Have a phone call for work while you're doing your yoga. Make an appointment. Set the mood. How about starlight above? Yeah, so that's their Bali little robot concept. And that was the last, I think, thing that I have. Here's a link where they talk about Bali a little bit more. Brad, thank you. It looks like you've confirmed my theory that it's a parking robot. That Samsung one, so very nice.
Yeah, the HL Mando platform is for a parking robot.
Yeah.
They have the same picture on their website.
Yeah, I figured, but man, unless you read the fine print somewhere, there was no telling it from the displays. That was
yeah, and their website's not much better.
Yeah, what a lost opportunity. Okay, so I have now rambled for an hour. It was an hour after all. So I believe that is the sum total of my update from Planet Vegas.
Thanks for bringing Vegas to us.
I hope you've enjoyed the tour. I've saved you from a lot of craziness.
Oh my God.
But if you'd like to go, it is fun.
I'm not over Vegas from Comdex when I used to have to go there. everywhere.
Yeah, I did that one too.
Oh my God.
So I'll make a PDF of those slides and I'll send it to Doug. So if you want to pull links out that I've embedded in there that aren't in the chat, but anyhow, cool stuff. Yeah, the future is bright if we can survive the dystopian parts of it. Okay, that takes us to open mic night, open mic time. So I yield the floor.
I got one thing.
I've got something as well.
Cool. Who is that after Harold? Pat. Okay, good. Thanks.
My thing's pretty simple. Do you cats know who Lanny is? Here, let me get out. Video URL. And if you want to pin me a little bit. Hello, we're not that slow here. So video came across my feed just a few days ago. And I don't know if you heard me talk about regrets. I got this little joke thing that goes on about regrets and stuff. And how most of my regrets end up being I should have asked that girl out and didn't. Should have asked her for a dance and didn't. But as far as those are not really real regrets. One of my big regrets is, where did it go? Oh, come on, no. I did not ask for you. Really? I guess I can't drive tonight. Where did it go? Come on. History. Yeah, we'll do it this way. The link to this is in the video. Now this cat is named Lanny something or other. Keep forgetting his last name. Comes in my biggest regret is I never even tried to be an Imagineer. Never even tried. This guy is getting I got the volume turned down here because I'm going to skip through it because you can watch it. And you got something in Lanny Smoot. Anybody ever heard of him? Anybody?
Not since you sent the link the other day.
No, since I sent the link the other day. You've seen this, right? I know you've seen this, Carl, right?
I haven't been able to watch it yet. So
okay, so here we go. So Lanny Smoot, he's a Disney fellow, and he's about to receive the Inventor of the Year award. And the only other person from Disney that's ever got this is Walt. So big deal. And if I was an engine Imagineer, I might have been able to work with this guy or been around him, or at least talk to him. And I want you to watch the video because it goes through with some of his inventions, what he's doing. He's got some eyeballs. Those eyeballs right there. They work on electromagnetism to move around, and they've got easing functions and all that kind of stuff. And it's one of the things he built. Something like to make the models and the animatronics more lifelike and more correct sizes. And I'm like, that would be cool. And he's built some other things there too that you may or may not know and dig. And like he also built this thing. This is a fully retractable lightsaber. And that's been around for a while. But that's Inventors Hall of Fame. So, but that's not the cool tech. All that cool was, he has something here he shows off called holographic tiles. and he's walking on these tiles, any direction. And I think, you know, like anything else, you start small and make it big, and then you make it fast. Two people walking in two directions at the same time. And so this is something he's invented, and it's coming. And I'm like, that's pretty darn amazing. So it's 4 minutes of your time, paying a little respect to the Lanny, and this is just simply amazing. Amazing, cool. So anyway, put it on your watch list. Check it out. See that they're moving that box around with the holographic tiles. And you got to know, if they've got that in a little thing like that, I don't know how many years it's going to be before we actually see this thing or have experience with it somewhere in the park. But you know it's coming. They don't pretty much don't build stuff that don't show up in a park somewhere and don't end up being in things. You know, that's just how they work. Anyway, that's about all I got on that whole deal. I mean, I got other things going on too, but I wanted to show that off, and also wanted to show the other link that I put in there, the sphere that the guy builds himself. He built like this 4 or 6 foot across one, like no one's building that. He built a small one using strips of NeoPixels about that big across.
Yeah,
and it looked and I don't know how he did to do all the stuff, and I'm like, I'm not going to buy that many NeoPixels, but it looks really cool, and you make your own sphere on that deal. Anyway, that's all I got.
Cool.
Hope you folks thought that was at least a little cool.
Inspiring.
Yeah.
Or humbling. I don't know, something like that.
Both of those things at the same time. And again, my biggest regret is I never even sent an application. And like, well, Harold, you can do that now. Well, you're absolutely right. I can do that now. But there's some realities now that wasn't the same reality as when I was 20 years old. So,
right.
Yeah, you know, a little different there.
It's all good.
Yeah.
Well, cool. All right. So, Pat.
Hey, everybody. I got a video to share of a robot. See if I can get it going here. Can everybody see my screen?
Yeah.
I've got the volume off. And this guy built a boiler log feeding robot. I don't know if you can see that video fairly well.
Well, that's pretty wild. So do you guys, is this common way to heat houses up there?
I don't know where this guy is. Basically, I'm not sure, but he's heating
the robot.
A wood-fired boiler.
Part 12.
Hey, that's a nice compressor.
So he's manually loading a rack to, I guess, for the robot to pick the logs out of.
Needs a robot to fill the rack.
Yeah, then it needs to chop and split.
Yeah, exactly.
It's a great robot. Yeah.
I don't know. The robot's moving and he's moving in and about it. I don't know if that's a smart idea.
Oh, that was a cool little display that
he had there. Display on his phone, I think, for it.
So you're saying this is one thing that people do when it's so cold outside is make robots like this?
I'm guessing. I come across this today and I said, this is pretty interesting.
Did you see how it kind of lined up? It went back and forth a couple times to line up on a log.
Yeah, I mean, they're not the most well-behaved, consistent things, are they?
No. And then when you look at it, he goes a little farther and he starts going into some of his Arduino code.
All right.
So I'll put the link up for this thing. If anyone's interested, they could watch it.
But this is like playing with fire, because what happens if there's literally playing with fire?
I guess he didn't want to invest in a pellet stove. You know, you can have the automatic feeders with the pellets. And
That'd be too easy. That'd be too easy.
Yeah, misload has a pretty high consequences with it.
It really does. That guy's all in.
Especially if it happens in the middle of the night
Yeah,
when he's resting.
right. Yeah. And how much do you want to bet that he's not exactly around the corner from the nearest hospital?
Hey, Pat, does Canada have I don't know, criteria, I guess, like a lot of the wood burning stoves now actually burn the smoke that comes off, wood or something like that, or it's recirculated to burn smoke?
Yeah, a lot of the stoves will they're higher efficiency than they used to be, and they will reburn the gases.
Yeah,
inside the stoves.
Yeah, that looked like it might have been one because a lot of them are downdraft. The wood is, or the chamber that burns the wood is actually up on top, and it actually pulls the smoke down through and recirculates it. Yeah.
Yeah, so they've got all sorts. I don't heat with wood here, so I've got like a gas furnace in the house, and I've got a gas furnace in my garage. So
nice.
Cool. So I might consider it though for my brother-in-law's garage. He's got a wood-fired a wood stove in his garage.
Ah.
I just thought it was an interesting video. I come across it on Weekly Robotics.
That's pretty cool.
Yep. That's it for me. I've just the other one is I bought on AliExpress.
Whoa.
Uno Minima R4. A clone for about $15 Canadian. So
that's
surprisingly, it's not branded as Arduino. It's just branded as a Uno Minima R4.
Yeah.
And
seems to
come
work
in today. I just put a quick program in it to make sure it would work, and everything looked good.
Yeah, blinky.
Yeah, exactly.
Very nice.
That's it for me.
Okay, cool. Thank you very much. And Brendan, you here? I think you got the hand raised in the chat thing.
Oh, no, I must have accidentally hit that. No.
No worries. It goes up and down so often I can't keep track of it, but okay. All right. Where does that leave us? Any other open mic night interest? I hope I didn't wear everybody out with my rambling, but
No, that was awesome, man. So yeah. I missed the first part. Why were you at CES? And I've never been able to go, so I'm so jealous of you and Jonathan and a few of my other friends that have gone.
I never said why I went this time. It was for my company. We were looking for things that could help with our company. So we were looking at senior related age tech, health tech kinds of things, and either products that we could use or partners that we could work with. In my way of thinking, it was a kind of a stretch for that, but there's some potential. We'll see.
Yeah, that last product. Yeah.
The last one.
Hey,
oh yeah, Molly. Sure. Yeah.
Molly. Yeah.
Although for people with dementia and Alzheimer's, I don't know. It's I think they have trouble relating to things that aren't human faces.
Might get kicked across the room.
Yeah. Right. But eventually, I mean, the Japanese are certainly working on human companion bots like that. And there's all kinds of, like, believe it or not, from what I understand, it's pretty common for people in memory care facilities to have dolls or pets that they can carry around because they remind them, they think they're real. So it's actually, if you go to the marketplace stores for Alzheimer's, you can find little robot cats and dogs that make all the right sounds and behave that way and that they expect. And So there's something there. And I think as these voice interfaces get coupled with the large language models and the interactions become more and more natural, yeah, there's something there. Oh yeah, and that brings up, okay, so I haven't clipped any articles like this, but last month it seemed like every other day there was another article on some person who has formed a romantic relationship with an AI. It's like, okay, come on.
Hey, I'm trying
to make a movie about that.
Yeah, I think they have, but I mean, the movie's one thing, but there's people in the real world. And then just as the one-upsmanship goes, then I found another article. Somebody decided they had a romantic relationship with a tree. So they okay.
It was great until he started getting splinters. Right?
Oh, hey.
I think the article talked about that, but anyhow, okay, well, this robot thing is way off course now. We've totally lost it. Okay, well, if there's no other, this is a second last call or so. Gentlemen, have a good weekend, a good week. Stay warm, stay dry. Don't float away from San Diego, and we'll catch you next Tuesday night.
Hey, who's on the ballot for?
Well, from what I hear, I might be listed as VP, but I don't feel comfortable announcing the others.
Okay.
They need to speak for themselves.
Okay.
Oh, somebody else other than Carl. Whoa,
Paul.
Get out of here.
Where is Paul? Wow.
It's gotta be Paul.
Where is he right now? Yeah, bummed.
Preparing.
Yes, Harold, elections mark these dates, Harold. February 10 for an election, DPRG election, and planning meeting for this year. So there's talk of like trying to reboot the club after I've just let it do what we've done in the last few years.
Was that going to be live? Is it going to be at the Makerspace or?
I think it'll be hybrid. So I've reserved a room at the Makerspace on Saturday the 10th. And but then I'm sure we'll have a remote thing as well, because I mean, we have so many good participants remotely. And then Kareem, somewhere in the chat, listed a couple dates. He's looking for judges for some tournaments coming up. And then on April 27, we're going to have Roborama this year. So April 27 is a practice day at the Makerspace in person.
Oh, we don't have time.
And then May 11 is the competition, indoor competition. So we'll put more on those later.
I had a question. Paul's not here, I guess, today, but I was wondering if he had started his ROS 2 telemetry workshop.
Yeah, we had our first session last Wednesday.
Cool. How'd it go?
No, it went well. Many of us were enthusiastic and actually had worked ahead. So we'll meet again tomorrow. 6 weeks, meeting every Wednesday.
Pretty cool. That sounds like there's going to be some serious ROS drops going on here soon.
All right. Thanks.
Okay. All right. Well, gentlemen, bid you a good evening. Good week.
Good night.
Talk to you later.
Thank you.
Okay. Hit the stop button.